We have one question from the chapter straight line. It says, assume that the straight line work as a plane mirror for a point. Find the image of the point 1, 2 on this line. So what I'll do, let's say if I take one straight line, I took this as straight line and considering this to be a plane mirror. There is a point, let's say I take this point as P and its coordinate is given as 1, 2 and its image, right? So you know that distance of the object is same as, or the distance of the image from the mirror is same as the distance of the object from the mirror. So I can take this point, say x1, y1 as the point, and this being the point of incidence. And you know that using this laws of reflection, is it laws? We can say that distance of the image from the plane mirror is same as the distance of the object. So we can say that L is the midpoint, and I take this point as say HK. And we know the equation of this plane mirror, and the equation is mentioned as x minus 3y plus 4 is equal to 0. So the information depicted using the diagram. Now, what next we are going to do is to apply the different properties. So the properties which we'll be applying, let's say if I keep it aside. First of all, we know the equation of this line. So uh, let's obtain the slope of this line. So what should be the slope of this line? Using minus a by b, we can say m1 is minus a over b is this. So the slope of this line is 1 over 3. Now check here, these two lines are perpendicular. So the slope of this line is going to be what? Negative reciprocal of this, which is minus 3. So I take this as ms minus 3. Now from here, as you can see, we know one slope and one point, so we can obtain the equation of this line, say P dash. So if I have to obtain the equation of this line, I'll say y minus y1, well, y1 is 2 here, is equal to m, which is minus 3, x minus x1. X is x minus x1. So I can simplify this. So this is y minus 2 is equal to minus 3x plus 3. On further simplification, 3x plus y is equal to 5. Now check here, we got the equation of this line and I mark this equation. Let's say if I mark this as say 1, this is equation 1 here. And the other equation is what? The other equation is x minus 3y plus or is equal to 4 is equal to 4 or 4 or minus 4. It should be minus 4. Now you can figure out from the diagram also that this point L lies on both the line, right? This lies on the point of intersection. So HK will satisfy both the equation. Now we can first of all, let's place H and K over here. So this equation transforms as what? 3H plus Y. Y is K, right? Y is K. So K 3Y 3K 3H plus K is equal to 5. And similarly, if I plug in HK over here, it should give you what? H minus 3K is equal to minus 4. Now, as we discussed already that L is the midpoint of PP dash, so we can obtain the coordinate of H, and H is what? X1 plus X2 upon 2. As you know that special case of section formula, X1 plus X2 upon 2 is H. This is H. And how did I get? Using the section formula. Now, similarly, we can obtain K also. So K is what? Y1 plus Y1 plus Y2. Well, Y2 is 2 here. That divided by 2. Now, you know that this point will satisfy both the equation. So we can plug in the value of H and K over here. So let's say in the first part, I'm going to replace this H and K using this. So what is this H and K? Replacing this 3 times H, and H is this 3 times x1 plus 1 over 2 plus K is what? Y1 plus 2 over 2 is equal to 5. So on simplify, you can see we have same LCM. So 2 into same denominator. So LCM is 10. On transposing 2 to the other side, this is 3 times x1 plus 3 plus y1 plus 2. So this gives you what? 3x1 plus y1 plus 5, right? And if I take 5 on the other side, it is 10 minus 5 as 5. So this gives one relation between x1 and y1. And the other relation can be obtained by placing the value of h and k here. So once again, h I am replacing with the same, which is x1 plus 1 over 2 minus 3 times k, and k is what? K is this. So if I solve this, what I'll get here, this is 3 times y1 plus 2 over 2 is equal to minus 4. Using the same concepts, if I transpose 2 on the other side, it is minus 8. And this is what? x1 plus 1 minus 3y1 minus 6. In the last step, we'll write x1 minus 3y1. And this is how much? This is minus 5 on the left hand side, right? So on the other side, it will be added, right? So this is minus 5 minus 8 added with 5. So that's why we get x1 minus 3y1 is equal to minus 3. So check here, we got two equation in terms of x1, y1. One is this, and the other is this. The other is this one. So we are going to solve these two equation here to get the final answer. Now to solve this equation, what I'll do, we'll do elimination method, and it can be solved over here. So for the first equation, let's say this I take, if I multiply 3 on this equation, right? So why I'm doing so as to equate their y coefficient. So this is what? 9 times x1 plus 3 times y1 is equal to 15, and this with multiplying with 1 only, this is what? x1 minus 3y1 is equal to minus 3. Well, I'll add these two equations. As you can see, on adding this will get cancelled. This is how much? 10 times x1. And on the other side, it's what? 12 minus 15 minus 3, which is 12. So x1 comes out to be 6 over 5. Now check, once we get the value of x1, we can obtain y1 by replacing x1, say, on this equation, right? Here I'm doing this. So over here, I'm replacing x1. So this is 3 times x1, and x1 is what? 6 over 5 plus y1 is equal to 5. So y1 should give you what? 5 minus, this is how much? 18, right? This is 18 over 5. So y1 comes out to be what? This is 25 minus 18. 25 minus 18 is what? 7 over 5. So we get the value of y1 as this and x1 as this. Now check, this is what we had to get. That is the coordinate of the image. So we'll say that the coordinate of the image so is 6 over 5 comma 7 over 5. That's the answer.